Good morning, or good afternoon, depending on when you're watching the video, I guess, or good evening. Uh, so we're starting a brand new unit. We're going to move out of trigonometry and we're going to go into this unit that's on recursive functions, which is just like a sequence of numbers, and you can see on the notes. It's going to be a pattern of numbers, a sequence of numbers that have some kind of pattern that you can figure out. Now we're going to be doing a lot of work with arithmetic ones, which are ones that are adding the same thing over and over, and we'll talk about that. And geometric ones, which is you're going to multiply the same number over and over. And the first sequence I gave you was just a basic arithmetic sequence of numbers where you can tell they're increasing by 3 every single time. But before we get into all of the how-tos and what-to-dos and formulas and all that, just wanted to look at notation so that you understand what you're looking at with all this different formula stuff. So if so A is the name of this sequence of numbers, and it's an infinite sequence. ... at the end means it's going to keep on going. And then each one of these is called a term. So 4 is the first term, 7 is the second term, 10 is the third term, so forth. So each one has a term name. And then to identify that term, we use, that's what number 1 is, we use a subscript. So a sub 5, or when you see that a with that little 5 after it, it's called a subscript. A sub 5 is what is the 5th term of the sequence. So if we look 1, 2, 3, 4, 5, you'd say a sub 5 is 16. That's it. You're not doing any kind of math or anything. You're just identifying the term. A sub 8, 1, 2, 3, 4, 5, 6, 7, 8 is 25. So the number of the term is called n. So n would be 1 for this one, 2, 3, 4, 5. So we see the 5th term is 16, 6, 7, 8, 9, 10. 10th term, 8th term was 25, 10th term 11, 12, 13, 14, and of course you could go on. But each one has a term number. So the 12th term, a sub 12, is 37. A sub 14 is 43. So very simple to do. A sub 1. This is going to come up a lot in what we do. A sub 1 is the first term, which of course is 4. And it's going to be used in the formulas we're going to use later on and some of the things we have to manipulate to solve things. So A sub 1 is a big thing in the pattern. A sub 15. Well, we only have the first 14 terms, but you can find A sub 15 because the pattern continues. If you know the pattern, you can get 15. So that'd be 3 more, should be 46. And 18 and 22, so let's just go ahead. 15, 16, 17, 18, 19, 20. Oh, I'm going to run out of room. Move over a little bit. 21, 22. So 46, the next one would be 49, 3 more. 3 more would be 52. If you look, with this pattern of adding, they're always going to have a common n number, like 4, 7, 0, 3, 6, 9, 2, 5, 8, 1, 4, 7, 0. So the next one would have to end in 3. The next one is, so yeah, so we're on the 6 and then the 9, and then the 2. So this one has to end in 5, right? So 55, and 3 more would be 58. 3 more would be 61. 3 more would be 64, 67. So if we make it, that was 15, 16, 17, 18, 19, 20, 21, 22. Yeah, so 18 was 15, 16, 17, 18, 55. And 22, 67. All right. So then getting into these notations where there's things going on in the subscript, that is a sub 7 minus 1. Well, if that whole 7 minus 1 is in the subscript, that's the same as saying a sub 6. Or, starting with the 7th term, which is 22, if you go back 1 minus 1, you would be at a sub 6. 7 minus 1. So that is, if a sub 7 is 22, then the term before it is 19. So if you're subtracting 1 in the subscript, and that's a whole lot different than having, if you had a sub 7 and then minus 1 as the operation after it, that's different. And we don't do a whole lot of that, but that would be take the 7th term and subtract 1 from it. That is not what this is saying. Same thing here. What is a sub 12 minus 1? Well, if the 12th term is 37, then the 1 before it, the 12th minus 1, would be the 11th term is 34. So if you look at this one, it's saying, what is the 9th term, 1 after it, right? If you find the 9th term, what's the next one? So if the 9th term is 28, then the next one is 31. Because that would be the same as the 10th term, right? This would be the same as the 11th term. And then every once in a while we need to go 2 in front or 2 before. This says if you find the 11th term, what is 2 after it? Right? So the 11th term is 34. 2 more terms would be 40. Or, that is a sub 11 plus 2 is 13. Now, when it's all numbers, that makes sense. And you can just do the math first if you wanted to. But in cases where it's a sub n, and a sub n is going to come up a lot. And a sub n is just what's called the nth term. We'll write that up here. A sub n is called the nth term. And it's kind of like an unknown term. It's a variable. You're not sure which one it is, but it is some term in there. And we're going to use formulas to find the nth term, especially when you don't have a list like this, or if the nth term is well beyond what you want to make your list to. So here, if a sub n is 22, well, we know, if looking at the pattern, 22 is here. So that is the 7th term, right? But it's saying if a sub n is 22, what's a sub n minus 1? What is 1 term before it? So if you're at 22, then n minus 1 must be at 19. All right? And next one. If a sub 34, if a sub n is 34, then what's a sub n minus 1? Who knows it? Raise your hand. No, I'm kidding. You probably already know. Oh, up here. So if we are 34, if you're at the 34, what's the term before it? That's right, 31. This time, if you're starting at 31, what is 2 terms before it? So a sub n minus 2 would be starting at 31, count back 2 terms. 1, 2, you would be at 25. And the last one, if a sub n is 13, what is a sub n plus 1? So what's 1 after? So if we're at 13, what's the plus 1? If you go up 1 term, you would be at 16. Good. Not too bad, right? So this is all just like practicing understanding all these a sub n's. And then finally, we can write what's called a recursive function based on all of this stuff. And how we write that is, any term a sub n we have is going to be the term before it. So a recursive function is always going to relate the term, any term that you want, to the term before it, and then what's happening each time. So in other words, if a sub n is 25, what did we do to the term before it to get that answer, the 22? If the nth term is 37, what do you do to 34 to get that answer? So each time, like we said at the beginning, you are adding 3. So if I give you any term, you can just add 3 to it and you could get the next term. And remember, this minus 1 is just a notation. You're not subtracting 1 from any term. It's just the term before it. Alright, so this is a good description of what's going on, but without any knowledge, if I just gave you this and told you to write a pattern of numbers, would you come up with 4, 7? Well, it depends. Why would you start at 4 if this was the only information you're given? And you might not. So in any recursive function like this, you have to tell also what is the beginning. That's why I'm saying that a sub 1 is important, because that's where you begin. So not only you're adding 3 every time, but always start with the number 4 for this pattern. So that is your recursive function. Alright, just basic so far. So your assignment, it looks just like this, except for it says worksheet instead of notes. So open that up, and it's going to be another pattern. Pay attention. It's not the same terms in it, but it's the same idea. And then write the function for that one. And use your math type to write this out on your Canvas. Submit that to me, and great. All right, good to see you all. Hope you're doing well. Let me know if you have any questions or concerns, and have a great day. Talk to you soon. Bye.